take 2 points on the circumference of a circle, A and B, forming an arc, AB, and draw lines from each of these points up to the top of the circumference here, it forms an angle which we're going to call angle X. Just write that in. And then if I take 2 more lines, 2 radii in fact, from each of these points, so they go to the centre of the circle here, then the angle formed by those 2 lines at the centre is going to be twice the size of the angle at the circumference, so long as both sets of lines are drawn from the same points down here, from this same arc AB. So if this angle at the centre is twice the value of the angle at the circumference, then we can call this angle 2x, because it's twice as big as x at the top. Now this is a rule, this is a theory of circles that you've got to know, and you've got to learn it for the exam. But the examiners are quite tricky, and they won't necessarily give you a question that looks like this. They will disguise it somehow, and I'm going to show you how they disguise it so that you can spot that it's actually this rule that you need to know and apply. Take a look at this circle here. This is one of the ways in which you might see this rule disguised. We've got this angle here, 67 degrees, and we've got this other angle here which we need to find, A degrees. We need to work out what the value of this angle is. At first sight it may look a bit tricky, you don't know how to start, but once you do a bit of detective work you can see that both of these angles are formed from these points on the circumference, from these same 2 points. There's an arc here, AB, and from these points on the circumference we have one angle up here at the circumference, which is 67 degrees, and another angle here, which is A degrees at the centre. Even though the shape cast by these lines is slightly different from the one we've just seen here, the actual situation is the same. And you need to be able to spot that, because once you do, it's very easy. If we know that the angle at the centre, in this case A degrees, is twice the size of the angle at the circumference, then we know that A degrees is equal to 2 multiplied by 67 degrees. And if we work that out, 2 times 67 is 134 degrees. Now take a look at this situation. We have a quadrilateral here drawn in this half of the circle. We've got an angle given to us, 110 degrees here at the centre of the circle, and another angle at the circumference. At first glance this looks nothing like this, but again when you notice that both sets of lines are drawn from the same points on the circumference, then you realise that it is the same situation as this. But what it is important to notice is that the arc from which these lines are drawn is not A, B, it's actually in this direction, A, all the way round to B. So it's this angle here, this reflex angle, which is twice as big as this angle, B. So if we draw this in, just to make it more obvious, we can see that this angle at the centre of the circle is twice as big as this angle at the circumference. It's a reflex angle, so it looks different to this shape, but the properties of it are the same. So if this angle is twice as big as this angle, we can call this angle 2b, because it's twice as big as b. And then we can use this known angle, 110 degrees, to help us work out 2b, because we know that the angles around a point add up to 360 degrees. So 2b is going to be equal to 360 degrees minus 110 degrees. And the answer to that is 250 degrees. So 2b is equal to 250 degrees. And at 2b, this angle, is 250, then b, which is half the size of 2b, obviously, is going to be equal to 250 divided by 2, which is equal to 125 degrees. This is the law you need to learn, but you need to practice recognising how it's applied, because the exam will probably give you questions that look something like either of these two. And particularly if you're aiming for the higher grades, then you need to be able to recognise that what you're looking at is actually this.